to introduce automatic speech recognition. So this is some brief tutorial together with some introduction, some handy tools, models, APIs, and also some hands-on testing of all these kinds of speech recognition techniques and the tools. So recently, as the advancement of the deep learning, generative AI, the speech AI actually revolutionized the way the way we talk and communicate. So the speech AI technique actually refers to the use of the artificial intelligence for the voice-based application and services. It allows the machine to understand, transcribe, and synthesize human voice, and it actually consists of the automatic speech recognition, speech to text, and the text to speech synthetic techniques. So for example, in my previous session on the introduction of the Riva text to speech video, you can to refer to the previous video for some quick look. Also, there are many use cases for the speech AI, such like the voice virtual assistant. For example, I just build some the first prototype of ChatGPT powered voice virtual assistant in my previous video, and you can also take a look. And also many other use cases like digital avatar, voice activated robot, speech translation, and many more. So here is the relationship between the AI, machine learning, deep learning, and the speech AI. Actually, machine learning is just a branch of artificial intelligence, okay? And the deep learning is a sub-area in machine learning. Machine learning actually is partially overlapping with the concept of the convolutional AI. And speech AI is actually have something to do with both convolutional AI, machine learning, and deep learning. So here comes to the focus of today's presentation, which is the automatic speech recognition, ASR. So let's get started. So basically the ASR is a kind of the AI technology. Well, traditionally it's not using AI, okay? So it's a technology to allow the machines to recognize and transcribe the spoken language into the text. So spoken language understanding, as we know, is very challenging. It's a hard problem to solve. Actually, the ASR, tackles this challenging, computationally. So basically, and it actually converts, from an acoustic signal, speech sound, into a text string. So there are many popular, the products such like the Apple's Siri, the Amazon's Alexa, and Google's Assistant, and many more. So there is some brief history introduction about the ASR automatic speech recognition techniques. So originally, all the initial ASR system are rule-based, and trace back into the 1930s. The speech synthesizer called Model was invented by Bell Labs by that time, almost like the many years ago. Okay, so then the 20 years later, a system called Audrey, was invented by the Bell Labs again, which is capable of transcribing, the 10 digits from 0 to 9 only. So, however, by that time, an important discovery was made that a relationship between a speech sound and its signal spectrum, was discovered. So that is the distribution of the power of voice sound across the different frequencies. Okay, so that actually lays the foundation for the starting of the modern speech recognition. Okay, then 10 years later, IBM got some shoebox project, which actually they are managed to improve the vocabulary size to 16 from 10 to 16. For recognize the spoken language. Okay, and then another 14 years later, so CMU happy was invented and developed, which actually improves the vocabulary for the recognition to 1,000 the vocabularies. Okay, so then the time fastly moved to into the 2000s, just like 23 years ago. So then we saw like the birth of the statistical algorithms. So by that time, the statistical the approach the managed to recognize tens of thousands of spoken words. But however, it still has some issues such like the fixed accuracy, and you have to align the time boundaries between the audio segment and its corresponding text transcript. So then at almost the same like AI breakthrough for the image classification in 2014. So okay, almost 9 years ago, we saw like the birth of the deep learning based automatic speech recognition systems. So such kind of deep learning based like models is capable of the understanding complex patterns in the speech that can also customize for your domain-specific jargons and corporate lingos and abbreviations and terminology. For example, if we are working in the healthcare industry, it has its own like the specific terminologies and keywords. Also, the deep learning approach is capable of contextualizing the words, which means like for example, the two different words with the same pronunciation, such like the flower in my garden and I use flower powder to make bread. They actually the different words with same pronunciation and have different meanings. So the deep learning approach is able to recognize them as well. So and tell them apart. Also, the deep learning approach is robust to the background noise as well. So here is the deep learning based SI architecture and whole end-to-end pipeline. So initially, you got some like the audio input. For example, you can speak, say, AI is cool, okay? Then we got some like the feature extraction model to actually to process it. Then output of the feature expression get into the acoustic model, then get into the decode and the language model to transcribe the voice into the text. And also in the post-processing stage, we have the punctuation and the capitalization models, as well as the inverse text normalization model. Finally, you got some nice, the text transcription, the ready. AI is cool. That is the whole end-to-end. Okay. So let's take a look at each individual component in the SI pipeline. So first of all, feature extraction, actually converts the audio, the speech sound into the spectrum or the male spectrum, which is actually the visual presentation of the audio signal over the time, at the different frequencies. Okay. After you got this kind of like the spectrum or male spectrum representation of your speech sound, so your audio signal, then we can get this into the as input into the acoustic model. So that can just like the the output a matrix of the character token probabilities. That is the probabilistic distribution over the vocabulary tokens for each time step. So it basically tells us what token is most likely spoken at each time step. So notice here, you can customize the acoustic model to better recognize your specific accent and dialogue. So we also like introduce some like the product and the model which can do this kind of work. Okay. Then once the acoustic model generates the matrix of the token probabilistic. Then we get into the input into the Decode and language model. So the Decode language model put together all these tokens into the words and then in turn words into a sentence, where the best possible word sentence are selected by the decoder language model based on the final highest probability score. So here on the diagram on the left hand side, you can see this example decode working flow. So also notice that you can customize the language model to better recognize your own specific domain, vocabulary, and the jargon. Okay. So then at the post-processing stage, the punctuation and the capitalization models is used actually to improve the text quality for the better readability. So punctuation model just generates like punctuations for the raw transcript, okay? And then the capitalization model just like predicts the correct capitalizations of words in transcription. So last but not least, inverse text normalization, module, further improves the transcription accuracy. That is like the converts the normalized text into a better readable format. So that is some of the additional like the bells and whistles you have to do for the speech to text the task. So of course, if we want to like the text to speech on the opposite direction, you also need to do the text normalization, the functionality to actually to convert some like the words into the digitals into this is the written language, the text representation format. That's it. So then just recently we saw the coming of the even more powerful the deep learning based ISR model, so-called the all-in-one model. So all-in-one model, that is actually it is a single model replacing all these individual modules, including the acoustic model, decode language model, and punctuation and capitalization model. So we got some like good examples like the Whispers and the Conformers, and we are going to introduce them in bit details in just a second. Okay. So that is actually have a lot of the benefits. So first of all, a single SR model, have the higher, the transcription accuracy, because it can access like the shared representation, the abstract and efficient, the mathematical representation of both acoustical and the linguistic characteristics. Okay, so that is one power of the single SR model. Also, it is much simpler. You don't need to actually train individual models, anymore. It actually saves a lot of time and the money. Okay, and also it's reduced the runtime inference latency and support the even more use cases for the speech recognition. So here is a list of the top the very popular the SR models, APIs and tools. So for example, so the OpenAI Whisper model. So OpenAI is also the creator of the ChatGPT. Okay, recently everybody is getting crazy about it. Also the Nvidia's Riva Conformer Model. So this is another very powerful and very the advanced model, and we are going to introduce in seconds. Yeah. Also the Python speech recognition. This is the open source model, and not a model. It's actually the open source Python library, and the packages actually contains a lot of like the APIs and models and engines you can use. Okay, for the speech recognition purpose. Also, we also see the list have the Speechmatics and the Deepgram. Okay, so they are not the open source, and the Nvidia Riva Conformer is also not open source, but the OpenAI Whisper and the Python speech recognition package are the open source. Okay. So let's first introduce the Whisper. So I just quote like the the summary from the OpenAI. Okay, we have trained and are open sourcing a neural net called Visva that approaching human level robustness and accuracy on English speech recognition. This sounds great. Okay. So what is Whisper? So Whisper is a general purpose ISR model being trained on like the massive like the training data set which contains like 680,000 hours of the multilingual and multitask supervised audio data collected from the web. So actually the advantage of using such kind of large and diverse data set, including like it actually is leading to improved robustness to the accents, background noise, and jargon, technical languages, and the terms. Also, it enables Visva become a multitasking module capable of like multiple lingual SR, speech translation, language detection, and voice activity detection. So it has excellent generalization ability, can achieve zero-shot prediction across many diverse datasets. So what is zero-shot? It means like it can just like to predict the quite like the real the some like the audio recordings in some domain it never seen before. It never the trend on such kind of the domain data. Okay. So here is also like the enriched set like the paper, module card, and the code, source code to learn a bit more details about the Whisper model. And here also I include all the links here. So in nature, the Whisper is based on the popular transformer architecture. It as I said, is a single SR model all-in-one model with an encoder decoder transformer architecture, where multitasks are jointly represented as a sequence of tokens to be predicted by the decoder, so-called the sequence-to-sequence learning and prediction. Okay, so that is this some like the the advanced neural network architecture to enable it capable of doing the multilingual multitasking, the speech recognition. Okay. So actually there are the 9 versions of the Whisper model, okay, with the different sizes from tiny to the best, small, medium to large. Okay. So actually the Whisper model's performance varies depending on the language. Okay. So and on the right hand side the diagram you can see for some European languages like the Spanish, Italian, English, Portuguese, German, and even Japanese and Portugal, you look at this quite good. And for some other languages, when you move down to like the ranking list, like Nepal, okay, the Maurice, it actually becomes a bit worse. So you can see it's really depends on like what language you are trying to recognize. And the accuracy difference is also due to like the quantity and the quality of the training set which was used to training the Whisper model. Okay, obviously for like the English, Spanish, we got lots of like the training data available on the website on the internet, and the OpenAI can just use it for transcribe it. Yeah. Okay, so that is the some like the accuracy difference for different languages. Also here you can see the different size of the Whisper models. Generally speaking, the larger the size of the Whisper model, the better the transcription performance and the higher accuracy it is. So, however, that is also demand like the more and more memories, and also the transcription latency will be increased, like the model size increase. So there's always some like engineering trade-off, between the transcription accuracy and the speed and the memory demand. You have to balance for your specific use case. Okay. the second, strong candidate on our list is the Nvidia's Riva, and so Riva actually is a GPU accelerated SDK for building and deploying the speech AI applications. So it's a fully customizable for your use case, and also the delivering the real-time performance. So far today, to date, the April of 2023, it supports 14 languages, not as many as like the Whisper, and however, it's actually the performance for all the languages supported, most like the European language, is pretty good. It even has a web GUI for demo, and you can quickly try. Okay. So let's take a look. So this is like the OpenAI's the Whisper introduction page. So this is the Whisper's the open source the GitHub repo. You can see it got like the 32,000 stars. It's very popular. Okay. So this is Nvidia's Riva. Okay, the GitHub repo. And this is Riva's the Conformer Model model card and some overview introductions. So and let's actually take a look at the there are some the web GUI for demo. Here on this web page, you can just try to upload some like sample audio file, and it can transcribe for you. Also, you can just using your microphone to do it. For example, I can try. Hello, what's the weather like today? Look, see, you can quite quickly and accurately transcribe my speech song. That's very great. Brilliant. Okay. Okay, so let's actually going back. So it's many like the useful features from the Riva SR. So it's actually the have supporting the both offline batch processing and the streaming processing for transcription with low latency. It supports multiple acoustic model architecture options. Also, it can do like the automatic the punctuations additions. Also, is able to actually return the top transcribes from the beam decoder, able to do the inverse text normalizations and offline non-overlapping speaker diarizations as well. So the Riva, the speech skill is a toolkit for production, the convolutional AI inference. So we are going to actually do some hands-on lab on this, the package on this toolkit. Also, the Riva Speech API server, which is like the part of like the Riva Speech AI skills, the solution explores a simple API for performing the speech to text, text to speech, and a variety of the natural language processing inference. Okay. So Riva also supports like the full customizations of the end-to-end SI pipeline in the different ways. For example, during like the model training stage, you can either fine-tuning the acoustic model to better recognize some like dialects, some accents, or you can fine-tuning the language model to actually to better recognize your specific domain vocabulary, terminologies, and the jargon. Okay, or you can fine-tuning the punctuation models. Also, at the inference time, you can add in some like keywords to do like the keyword boosting. Okay, all these kind of the options and the techniques can help to improve the accuracy of the speech recognition. Okay, so Nvidia's Riva actually have many models to actually so among them, the Conformer model is the latest and the most powerful, the most accurate, the ISR model. So Conformer model, are good at like the capturing the content-based global, the dependencies and the interactions. Whereas, the convolutional neural network explores the local features efficiently. So such kind of thing like the conformer just like combine like the best parts from the both worlds, combine the both the convolutional neural network and the transformer to forming so-called like the convolution, the augmented transformer neural architecture. So that is can just like model the both local and global dependencies and features over audio sequence in a parameter efficient way. So it significantly outperforms some previous ISR models, achieving the state-of-the-art accuracies. So as we said, Riva, the toolkit supports the many ISR models, including the previous, the Jasper models, CrossNet, SpeechMatics, Conformer models, and many more. So we can see like the list of all the existing the ISR models available. Okay, so that is here. So Jasper is like the stand for just another speech recognizer. So it's a deep time delay neural network, the model. Okay. So the CrossNet is a version of the Jasper model, okay, with the separable convolutions and the larger filters. Okay. So and also the SpeechMatics is actually better than the previous Jasper and the CrossNet. Is a version of the the evolved enhanced version of the CrossNet that extends the context net utilizing the subword encoding and the sequence and the excitation mechanism. Okay, so context net it's also the model using the transducer recurrent neural network. Conformer-ctc is actually the Nvidia's the name for the conformer model we normally call it. So it is a non-autogressive model. It's actually achieve the state art. Before the conformer, just like the a couple of years ago, the CTRANet is actually the best model. Okay, so you can see like how fast the AI technology, especially in the speech AI, speech recognition domains, has been evolving recently. So also we have other versions of conformer models, fast conformer, and blah blah. Okay, all these kind of models available. Okay. As we see, so among all them, the conformer model is actually the best so far. Okay, achieving the state of art performance. Okay. So according to the Hugging Face, the ISR model leaderboard, they actually do some like the objective, the evaluations across different models, including the Whisper, Conformer, Web to Vec. So they based on some criteria and some like the benchmark dataset, so-called the ESB, the end-to-end speech recognition benchmark dataset, which contains about like 10 evaluation dataset. Then the ESB score is actually the word error rate, the average on all the 10 evaluation dataset. So you can see the lower the ESB score, the better the performance of the model. Okay. So the conformer, the INT model is 3 times smaller in size compared to the Visva model, but still achieving like some like similar, the accuracy score. So you can see on the top, the Vispa and the conformer is actually the, the win other, models, by some like the evident margin. Okay. So let's introduce interesting and the long-lasting and popular, the open source Python library for speech recognition. The name is just called the speech recognition. Okay. So it can perform in the speech recognition, supporting like a variety of the SR engines and APIs, both online and offline, such as like CMU, Phoenix, the Google Speech Recognition, Google Cloud Text-to-Speech API, with Microsoft Azure, Hondify, IBM, Snowboy, TensorFlow, Vosk, OpenAI Whisper, offline model, as well as the online APIs. So this is so many, okay? A dozen of the models and the APIs supported. So it have many, the use cases. It can recognize the speech input from the microphone. So in my previous videos, fast prototyping, ChatGPT powered, voice virtual assistant. I just using this speech recognition, ability. Also, it can transcribe an audio file, save the audio data to an audio file, show extended recognition results, calibrate recognize the energy thread for the ambient the noise levels, and listen to a microphone in the background and various other useful recognize features. So you can always refer to the speech recognition's the GitHub repo for more details. So yeah, so that is also the URL link for the GitHub repo. Okay. So also I'd like to actually to introduce another two non-open source, but it's actually the popular and the powerful solutions. One from the Speechmatics and another from the Deepgram. So both are the SR specialists providing the advanced speech recognition services. For the Speechmatics, it is a technology company based in the Cambridge, England, UK. Okay, it develops SR software based on the recurrent neural network and statistical language model. It's founded in 2006, by some ISR specialist, Dr. Tony Robinson. Okay, so and before you use it, you have to actually to get your own API key. So okay, so on the website, so you just like to get your API key following these instructions. Okay. Also, the Deepgram is a startup, the best in the San Francisco, USA, that provides a SR platform for the business. Their platform uses the deep learning to transcribe audio video content in real-time manner, supporting. So the one of its unique selling point is it can support like a wide range of audio video formats. So that is very useful for the business because businesses have the different formats of the audio video data to transcribe. Again, before you using the API, you can just like freely get some like API key from their website. Okay, so this is also the web, for the APIs request. Okay. Okay. So then, after the briefly introduce the theory of the automatic speech recognition, speech to text, let's do some hands-on session. So this is actually always my favorite part. Okay, so this is the moment of the truth. Okay, let's get started. So let's see like how all these kind of the OpenAI Whisper, Nvidia's Riva Conformer, Python open source speech recognitions with various engines support, Speechmatics and Deepgram performs. I'm going to do some like the comparisons using exactly the same audio file and do exactly the same like the assessment, the procedure and the same like the metrics for the accuracy, the latency measurements. Okay, so let's get started. Before you get started, yeah, just like install some like the Python library for calculating the word error rate. Okay, so this is our accuracy in the metrics. So this is straightforward, just like people install it. After that, you input all the like the dependencies libraries. Then you can compare like all the SRS models, APIs like for like, okay, using the same like audio sample. So here is my audio sample. So this audio sample is actually just like the audio segment of the adventure of the Sherlock Holmes, which I downloaded from the internet, which is like from some public open source. So you can always find the many open source, the public available the audio data samples to download. Let's take a look. And actually, this is just like the 1 minute and the 11 seconds, So that is quite short, the audio sample segments,
Name. In his eyes, she eclipses and predominates the whole of her sex. It was not that he felt any emotion akin to love for Irene Adler. All emotions, and that one particularly, were abhorrent to his cold, precise, but admirably balanced mind.
Okay, we're not going to finish listening all, but it's just like the 71 seconds, just like for our quick testing and the demo purpose. Okay, you can always like to try all these models using any the the audio clips you want. Okay. So first of all, let's actually do test and Whisper model. Okay, as we said, this is OpenAI's, the developer's latest robust speech recognition model, and this is like a single model, all-in-one model. Okay, so via the large-scale weak supervision techniques. So this is the GitHub repo. We already see it, and also as we just like to mention, so OpenAI take a state-centric approach. This is just based on like the normal transformer architecture, similar like the conformer, but actually they are using the very large and diverse dataset, so even across the multiple languages. So notice like in one of their document, they said the non-English, the training data account for the 1/3 of all the training samples. So that is a lot. So it's very robust, especially in the zero-shot learning for multilingual multitasking, tasks. So this is the instruction to install the Whisper step by step. So actually I tested and verified on my MacBook, so you can just follow it. So also, if you want to run it on some like the Linux like CentOS server, you can also follow these instructions. Then you can run in the Whisper either in command line or in the notebook. You running it like in Python programmatically. So if you're going to run it in command line, so the default settings is small. It's just choosing the small size the model. So it actually works well for the transcribing the English. So according to my experience, the small or best model is some good trade-off, between the transcription accuracy and the speed latency. And also the memory demand, because I can run in the small, tiny, and the best model in my MacBook without any problem. Of course, if you have the more powerful GPU servers have more memories, you can always run like a larger model of the Whisper. So there ahead, if you got some like error like the CUDA auto memory error or in PyTorch, you can just like using the tiny model instead. So this is just one single line code. Whisper audio sample well, specify the tiny model, then you can just like transcribe this kind of audio sample file. So here you can specify also the language and the model to transcribe other languages, and using the other like the models in different size. So also you can add the task, the translate, which will do the speech translation. For example, here I got some like audio file in Japanese, spoken Japanese language. So you can specify this is in origin like the audio file in Japanese, and then I'm going to using the base, the Whisper model, and the task is actually to just like to translate this Japanese speech into the English. Translation. That's it. So you can do it. So it's very straightforward. Also, you can run in the Whisper programmatically in Python. So here is code. Here I'm specified. I'm going to using the small, the Whisper model. Then this code I just like to calculate, what's like the transcription, the inference latency for this model, and then to get like the transcription result for this audio sample file. So you can see Whisper's transcription. To short Holmes, she's always the woman. So blah blah blah. So then the Whisper the transcription latency is just like a 4.4 seconds for 71 seconds, the raw audio file. So it's not bad. It's quite quick. And we are going to actually also compare with other models in the transcription accuracy and the latency. So also notice, you can see the punctuations has been automatically added. That is, the another evidence. The Whisper model is actually the all-in-one model. It actually including all the previous, the acoustic model, language model, and the punctuation model all in one. So that is the most advanced model so far. So also below is another example using the Whisper's detect language function and the Whisper's decode function. So that will actually give you the low-level access, to the Whisper's model's abilities. Okay, so what that is actually the code. So you can specify the model, you can load in your audio files, and then first thing you need to do is make the log mail spectrum, so a spectrogram, and move to the same device as the module, and then detect the spoken language. So and then you can decode and transcribe audios using this kind of the 2 lines of code. Okay, so you can see language detected English, and this is transcription. So very nice. Okay, so if we want to have the more control over the outcome of the Whisper transcription using the low level access, if we just want to do the transcription just using its high level transcription here. Okay, that's it. Okay, so this is for the Whisper. Let's look at the Nvidia's Riva modules. So as you see, the Riva speech, the AI, is a GPU accelerates the compute, the pipeline with optimized performance accuracy. So Riva provide a lot of the auto box, the standard art modules. So it can do the support multiple languages, mostly in Europe and Asia Pacific, like the English, Spanish, German, Russian. So far, as far as I know, it's supporting 14 different languages. Okay, so also you can see, if we look at it on this one, this all the current languages supported here. Okay, right. Okay, so let's actually move to our notebook. So so you can refer to the Riva's SR documentation for the more information about the Riva speech AI, the skills, the toolkit, and its ability strategy to training and the deploying any speech to text, text to speech models, NLP modules, and run it for the inference in the production environment and so on. So there are some prerequisites, you have to set up the Riva, first. So first of all, you need to actually to deploy and start the Riva speech AI skill server. So follow this instruction in the Riva quick start guide and to deploy the pre-trained SR model like the conformer. Okay, so on a local machine like the GPU server or a laptop with GPU, and then run sample the client before training this Riva part of the Handson notebook. So by default, only the English model are deployed. Okay, so this is some command. So this is the the quick start guide for the Riva. How can you just install the Riva the instance on your machine. So notice here this is some master in the have the prerequisites, because you do need to deploy locally up and running, get a Riva server up and running on the GPU, and before the training this part of the notebook for the SR. Okay, so then you can secondly you can just run in and store the Riva client library following this instruction. Then after the setup, you can just starting to do the transcription for the English in either streaming mode or the offline batch mode. Okay, so in streaming mode, a continuous stream of audio is captured and recognized, producing a stream of the transcribed text. In offline mode, an audio clip or set length is transcribed to text. Okay, so let's take a look at an example. Okay, so again, you also can run in the Riva to transfer audio in the command line. For example, so you first of all you start some the container with the sample client for each service. Okay, using this line code in command line, and then for offline recognition, you run this command. For a streaming recognition, you run this. Okay, so that is actually can give you some the nice the transcriptions SR speech recognition in either offline batch processing mode or the streaming the mode. Okay, which have the less transcription latency. Okay, let's actually run the Riva. Okay, programmatically in the Python. So first of all, you have to import the Riva client libraries. So and input the gRPC and the Riva client in the library. Then you create a Riva client and connect to the Riva speech API server. To the following the URL assume like the local deployment of Riva speech API server in the default port of the 500.5.1. Okay, so in case in the server deployed on a different host or on some Helm chart on Kubernetes using a proper the URI. Okay, so then you can just execute it and create the client connecting to the Riva speech API server. Okay, then you make a gRPC request to the Riva speech API server. So it's supporting the web the format with the PCM. Okay, and also the supporting the A law, MU law, and the flag in format with a single audio channel. Okay, so now let's remake some like a gRPC request to the Riva speech server. Okay, for ISR with a sample wave file in offline mode, starting by loading the audio. Okay, so this is the sample code. So here you can see, first of all, I set up an offline batch recognition request. Okay, this is the Riva client recognition instance. Okay, configuration instance. Okay, then you actually to specify like the language. Okay, so language code of the audio clips. So here you can specify like the American English or the like a British English or like Spanish, Portuguese, and so on, right? And then you can specify like a multiple alternatives. This is like means how many top N hypotheses to return. So and by default it only return like the top one, the transcriptions. But if you want to return like the top two transcriptions, the just like specify the number to 2 here. Okay, so also here this is enable like automatic punctuation. So you can see the conformer model is also the supporting like the automatic punctuation addition. So that means the conformer model is similar to the Whisper, is also the all-in-one ISR model. Okay, so then we specify the audio channel count. It's just like a mono audio channel with one channel only. Okay, so also another second option for like creating the recognition configuration is like this way. So both syntax is correct. Both syntax you can use either. Okay, so then you can use in the Riva to transcribe the given audio sample file. So this is we loading our sample file, and then I just calculate the time elapsed for the transcription to see like what's the transcription latency for the Riva, and then get my transcription the result. So you can see this is the Riva's transcription to Sherlock Holmes. She's always woman, has seldom her blah blah blah. So then the latency is amazing. This is just like less than 1 second for like the 71 seconds audio file. That is even faster than the Whisper. Okay, so that let's actually to before we do the all the like the quantitative like comparisons between the Whisper and the Riva Conformer, let's actually look at the other options like the open source Python package speech recognitions. As we said, it's supporting the many SI engines and APIs. For example, all these kind of a dozen also different SI APIs and the modules engines supported. So this is my current version of the speech recognition package I installed on my machine, and you can also install like the later versions as well. So this is my previous code, and to get audio from microphone and do the speech to text. But actually this is not going to need it for today. I just comment out. So then here I just like using the audio file as the audio source, and you can see this is just load some like audio samples, and then initialize the recognize the instance. Okay, then using the Google speech to text API, just for example, to recognize the audio. So of course here you can replace the instead of using the Google speech to text API, you can use in the other like the Microsoft Azure, IBM, WASC, and many other availables in the speech recognition the offerings. Okay, so again I just wanted it to give me the transcription result and also the latency for the transcription. Okay, you can see this is the result with some confidence levels, and what is the latency So, you see, this is the result transcription, but the latency is a bit long, yeah. So this is 35 seconds for only 71 seconds raw audio file. So that's much longer. The latency is much larger, than the Vispa and the Riva model. Okay, so and the security, we'll look at the security later on for some like the fair, the comparison, at the the end of this notebook. Okay, so also if we want to actually using all the other the APIs, just like the Microsoft Azure, IBM, Vite, Honeyfies, CMU, just actually refer to this notebook, which actually contains all the code for the using other APIs. Okay. So then the Speechmatics, as said, is a commercial company providing the the SR services, not open source. And for using it, you have to actually first of all to actually to the specify the URL you want to call, and then to get your the Speechmatics the API keys. So from their like website, then add the API key as like the to the authentication header. Okay, then this is utility functions so I define to send the file to be processed to the Speechmatics API and get the response ID back, okay, as the output, and then in another utility file to actually to take the like response ID as the input, and the request like the transcript results. Okay, so after I define all the utility functions, just use it. So just call this kind of 2 lines code, and then we get our transcription using Speechmatics API, and also the what could be delay it is. So here, this is the transcription result. This is the delay, 21 seconds. Okay, this is also a bit long. Okay, so and then let's look at the Deepgram, another commercial specialist in the advanced speech recognition service. Okay, so you can comment this line code to download and install the Deepgram SDK. Okay, then after you download it, input all the dependencies, and then here just like replace this placeholder with your own API key. Okay, so then actually this just like a single chunk of code. So you load your audio file samples, and then call this lines of the command, and to actually to call the Deepgrams in the SR APIs, okay, to actually transcribe your audios, okay. And then here you also can specify adding the punctuations and so on. So here this is the transcription result provided back from the Deepgram, and also the latency 1.3 seconds, not so bad. Okay, so moreover, so Deepgram also provide another enhanced TI. Okay, so basically when you actually to the send your transcription request in this demand, you can also specify the types enhanced. Okay, and also you can add some like the boosting keywords as well. So here is empty, but you can actually specify some. For example, if the model cannot recognize some specific jargons or corporate lingo in your speech domain, just adding those keywords here. Okay, so yeah, that's it. Then let's try also the enhanced tier with the Deepgram's SI transcription. So this is the result. You can see latency 2.25 seconds, not so bad. Okay. Then this is like the moment of the truth. Okay, so let's actually do some like-for-like transcription accuracy comparison, actually the both accuracy and latency comparison. So this is the utility functions because some transcription with punctuation some result. So let's actually just like remove all the like the special like the characters and the punctuations, and then remove all like excessive like white space, do some like-for-like comparisons. So this is utility functions to clean the transcript. Then I call the clean transcription utility function for all the results. Okay. Then I got some clean version of the transcriptions for each API, each models. So this is also the golden template. So this is the ground truth. That means this golden template contain like the accurate, like the absolutely correct, the transcription text the I expected from the any SR model. Okay, so and after done that, again, just clean the bits like translations and do the comparisons. So first of all, the latency, for the latency, I generate some like comparisons table. So from here, for the Whisper, Riva, Speechmatics, the speech recognition, Deepgram, here it is. So as you can see, in terms of latency, the Riva is the fastest SR, followed by the Deepgram and the Visva, So for 71 seconds, the raw audio sample, so Visva only take, 0.9 seconds, okay, less than 1 second. So followed by the Whisper 4.4 seconds, Deepgram 1.3 seconds, and others, is much slower, to return back, okay. And also calculate the word error rate for the accuracy comparison, like for like, okay. So here we call our, the word error rate into the Python library for comparison. So each like the transcription from each model API with our golden template, okay. So you can see Whisper, Riva, speech recognition, Speechmatics, Deepgram with like the enhancement as well. So here is the comparison table for the latency, okay. You can see like the Whisper for the latency, the Whisper, the Riva Conformer, and the Speechmatics actually are among the top, in terms of ISR accuracy, okay. And of course here, we just using a single, the audio sample for quick testing and demo purpose. So the audio is relatively easy. It's just like a native English speaker, right? So thus it's not like the comprehensive, nor is like the challenging, the comparison. So and also it's we cannot like draw any like the the comprehensive solid conclusion just for this kind of quick testing. So therefore, the key takeaway, I put here is actually just feel free to download this notebook and try using this notebook and together with like the tutorial and actually to learn, explore, and using your own audio samples to see like what's the difference and have fun. Okay, so that is a quick introductions. Okay, so just subscribe to this channel and keep updated on the latest AI machine learning trends. And as I said, download a copy of the slide deck and the notebook to do your like the own experiment. Have fun with the audio samples, different audio samples, different speech recognition models, techniques, and the APIs. And you can just like to have a lot of like the interesting findings by yourself. And in the meantime, you will gradually learn like the how to do the machine learning, how to actually to fine tuning some parameters and models, get some better performance, and customize it to a specific use case, plus many more free data science ebook and resource available for downloading and the sharing. Okay, so thank you a lot, everybody, and hope to see you next time. Okay.